Hi, in this video we are going to see about a Python IEEE project which is entitled as Cervical Cancer Prediction and Classification using Deep Learning on Medical Image Data, which is an enhancement of IEEE base paper titled A Novel Web Framework for Cervical Cancer Detection System, a Machine Learning Breakthrough, which is an IEEE 2024 journal paper. So before seeing the execution of the project, let me brief about this project. Basically, this cervical cancer is one of the most prevalent type of cancer affecting the women all over the world. It is developed in the cells of the cervix, which is the lower part of the uterus that connects to the vagina. So this disease typically begins as abnormal changes in the cervical cells, which if left untreated can progress to cancer over the time. So according to the WHO, World Health Organization, this cervical cancer is the fourth most common cancer among the women all over the world, which affects approximately 6 lakh new cases annually and 3 lakh deaths annually. So this cervical cancer is one of the dangerous disease that is affecting the woman all over the world. So we need to identify it early to get diagnosed. So in this base paper, so the authors have used the machine learning model for the detection of the cervical cancer. So in this base paper, the authors have used the web framework for cervical cancer detection system. So where they have integrated ensemble of machine learning classification algorithms, which include artificial neural network, AdaBoost, nearest neighbor, random forest classifier, support vector machine, and decision tree. And they have used numerical data set which contains the information about 858 patients with 36 attributes. So here you can see the attributes. So it is like attributes like age, total number of sexual partners, age of the first sexual intercourse, total number of pregnant, these kind of things. So here they have used the numerical data set, but kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about what we have enhanced from the base paper. So now we are going to use the medical image data. So the medical image data means this cervical cancer can be diagnosed through pap smears. So pap smears means a crucial screening process that include collecting the cervical cells for examination. So using those pap smear images, we are going to identify and we are going to use deep learning model. So for the deep learning model, we have used Xception architecture model, and we have achieved training accuracy of 93% and validation accuracy of 93%. So from the base paper, kindly note that we are not going to do the machine learning model. We are not going to use the numerical data set. Instead, we are going to use deep learning model, Xception architecture, and we are going to use the microscopic medical image data, that is pap smears, for the cervical cancer diagnosis. And there are 7 classes of it. Let me show you about that one right now. So in the dataset part, this is the important thing. Dataset part, we have train, test, and validation part. So all the train, test, validation part contain these 7 classes. So these are the 7 classes that we are going to predict and classify it. So here you can see the name of the classes, that carcinoma in situ, that is SCCSI, columnar CE, intermediate squamous, that is ISC, mild dysplasia, that is MSNKD, moderate dysplasia, that is MOSNKD, severe dysplasia, that is SSNKD, and superficial squamous, SSC. So these are the 7 classes. So in this, the healthy cells, what all the healthy cells means, this SSC, that is superficial squamous, is a healthy cell. Then intermediate squamous, ISC, is also healthy cells, and CE columnar is also healthy cells. The other 4 are abnormal cells. Let me show you those data set. Now in carcinoma in situ, you can see these are all the data set images that we are going to train the system. So these are all the pap smear images that is done through collecting the cervical cells. And next one, you can see columnar cells. So these are all the images that contain in the class columnar CE. Next, coming to the intermediate squamous. So here you can see those image data set. Next comes the mild dysplasia. So there are 1732 images in this class. So you can see those images data set that we are going to train the system. And next comes the moderate dysplasia. So these are the pap smear images that we are going to train in this class, which contain 1729 images. And then comes the severe dysplasia. So this also contains 1729 images. So these are all the dataset images that is going to be trained in this class. And finally the superficial squamous. So these are all the pap smear images of it. So we are going to use this medical images, pap smear images, to identify the cervical cancer, and we are going to classify it accordingly using the Xception architecture. So now let us come to the abstract document. So here you can see our proposed title, cervical cancer prediction classification using deep learning model on numerical image data. Then this is the IEEE base paper title, and this is the IEEE base paper abstract. So coming to our proposed project abstract. So as mentioned, cervical cancer is one of the leading cause for the cancer related deaths among the women worldwide. So early detection will be helpful for the survival. So here in this project, we are going to use the Python as the backend, and we are going to use HTML, CSS and JavaScript for the front end, and Flask as the web framework, and we are going to integrate using the Xception architecture, the deep learning model. So here the model is trained and validated. So whatever the data set that we have shown you, the data set name is Herlev dataset. So here this dataset total comprises of 17,304 images. So you can see the total size of the image, number of images of this dataset is 17,304 images, which contains 7 distinct classes, that is carcinoma in situ, mild dysplasia, moderate dysplasia, severe dysplasia, columnar, intermediate squamous and superficial squamous. So this dataset is split into, in training images we have around 12,110 training images, and validation images we contain 3,111 images, and test images contain 2,083 images. So whatever that I've shown you, that data set, so each contains with all these things. So as mentioned, you can see this is of the test cases of all the 7 classes, and same as like validation part contain these images. So totally there are around 17,300 images with the train of 12,110, validation of 3,111 and test of 2,083 images. So we have used Xception model architecture, and we have achieved 93% of the training accuracy and validation accuracy of 93%. And coming to the existing system, so as mentioned, we are going to take the base paper as the existing system. In the base paper they have used the ensemble of machine learning classification. Those algorithm details have been mentioned here, and here they have used the numerical data set. So this data set was obtained from the Peninsula Hospital. So the hospital name that has been managed in University of California. So this dataset contains 858 patient records with 36 attributes of it. And finally, biopsy is the final attribute that is going to target variable here. And using this base paper, the existing system is identifying. So what are the disadvantages of the existing systems? So the main disadvantage is they have limited use of the numerical data. So only with the numerical data they are going to predict whether there is cervical cancer or not, and there is no medical image analysis. This is not a scientific approach. So when we are using microscopic images of the cervical cells, it will clearly tell absolutely it is a scientific approach. And there's the other disadvantage is they have used smaller data size, which is around only 858 data set records, and they are used static features. And another disadvantage, generalization to diverse population, potential of model performance selling, and these are all the limitations that is being explained in the disadvantages of the existing system. And coming to the proposed system part, you can see that we are going to implement the cervical cancer prediction classification using deep learning on medical image data, and it is mentioned about the 7 distinct classes that we are going to use, and about the Xception architecture and the data set details, and the backend part and the coding front end part details have been discussed here. And finally we have summarized the details here. And coming to the advantages of proposed system, so the main advantage is we are using the medical image data, which is a scientific approach, so it will give the results perfectly. And we are going to use advanced deep learning model as Xception architecture, which is a high efficient and accurate deep learning model. And finally we have also achieved high classification accuracy, which is around 93%. And data set that we have utilized is also a standard data set, Herlev data set, which contains 17,304 medical images data set. And we have used a user-friendly web interface, that is another advantage, and support for early detection and scalable and adaptability. So these are all the disadvantages of proposed system that is being discussed in this part. And coming to the system architecture, so the input is Herlev dataset images, and pre-processing feature selection is made, and Xception architecture will be applied, and the predicted result will be any of the 7 classes that we have shown. And also finally we will show the performance analysis and the graph part. So next, the system requirement. So the hardware requirement, these are all the minimum hardware requirement that is needed to execute the project. And coming to the software requirements, so this project can be executed in Windows 10 or 11, and coding language uses Python 3.12.0, web framework is Flask, front-end part contains HTML, CSS, and the JavaScript. So this is the reference of the IEEE base paper. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python or the library installed in your system. So now go into the source code location. Inside that we have this computer aided cervical cancer diagnosis folder. Inside that we have the app.py file. So here in the address bar, just type cmd and click enter. So the command prompt window opens with the exact location of it. Now type python app.py and click enter, and kindly wait for a few minutes. So now after some time you can see this URL. Just copy this URL, go to any of your browser and go into Google Chrome, paste it and click enter. So after some time you can see this home screen or welcome screen with the project title, cervical cancer prediction and classification using deep learning on medical image data. So now just click this login menu. So now it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin, and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part where we need to upload the image for the prediction. So let me select the choose file. Now go into the source code location. So inside that we have given you the train and test, whichever you wanted you can select it. For the initially I'll just go with the test case and I'll just select and show you. So let me select an image randomly, and this is the image I have selected, and then click the submit button. So now it will be navigated to the prediction part where you can see the predicted result. So you can see the image that we have uploaded, and you can see the predicted result is carcinoma in situ, that is SCCSI. And if you wanted to check with other case, just select this preview menu again and select choose file. Now let me go to the other case and just select an image. and click submit. And now you can see the prediction result for this case is columnar CE. And now let me go to the preview menu again and just select choose file and just go to the other case and select an image and click submit. And now you can see the predicted result for this case is intermediate squamous IC. And now let me go to the preview menu again and let me select an other image from the other case and click submit. And now you can see the predicted result is mild dysplasia. And let me go to the preview menu again. Let me go to the choose file. And now let me go to the other case and select an image and click submit. And now you can see the predicted result with the image that you have selected is moderate dysplasia. And now let me go to the preview menu again. Let me go to choose file and let me go to the other case and select an image and click submit. And now you can see the predicted result is severe dysplasia. And now let me go to the preview menu again and let me choose file and let me go into the other case and select an image and click submit. And now you can see the predicted result is superficial squamous SSC. And let me go to the preview menu again. Now this time till now I have shown you with the test case folder. So you can also check with any other images that we have used for the training also. So let me go to some other images randomly. You can see there are lots and lots of images. I'll select an image randomly and then click submit. And now you can see the predicted result is columnar, so which was the correct one. So in this way you can check with the all other cases, 7 classes that is available in the train or test or validation part, and you can find the predicted result of it. So as mentioned earlier, the healthy cells or SSC, ISC and CE, and other cells, abnormal cells or other classes that is containing the other classes of the unhealthy cells, abnormal cells. And now let us move to the performance analysis part. So just click this performance analysis menu. It will be navigated to the performance analysis part. So in the performance analysis part, you can see the performance analysis of the exception architecture. So here you can see the class, 7 classes with the recall F1 and precision value. So the first class, carcinoma in situ SCCSI, contains recall of 0.96 and F1 score of 0.92 and precision of 0.89. Mild dysplasia MS-NKD contains recall of 0.93, F1 of 0.93 and precision of 0.92. And third class, moderate dysplasia MOS-NKD contains recall of 0.88, F1 of 0.90, precision of 0.93. And columnar CE class contains recall of 0.97, F1 of 0.97, precision of 0.97. And intermediate squamous ISC contains recall of 1, F1 score of 1 and precision of 1. And class superficial squamous SSC contains recall of 0.99, F1 of 0.91, precision of 1. And finally the class severe dysplasia SS-NKD contains recall of 0.87, F1 score of 0.88 and precision of 0.90. And finally you can see the confusion matrix, so the true and predicted label of the 7 classes. So this is about the performance analysis part. And finally comes the chart part. Kindly note that this is a static chart because we are not used any database in the project. So this chart is being depicted from the data set that we have used. So this is a static visualization chart which contains the class distribution of the class that we have used in the data set. So it contains carcinoma in situ of 14.3%, mild dysplasia of 14.3%, moderate dysplasia of 14.3%, columnar 14.3%, intermediate squamous at 14.3%, superficial squamous at 14.3%, severe dysplasia is 14.3%. So every part has been equally distributed, so that has been shown in the static visualization part. So now let me log out from this part, and before ending let me just show you the frequently asked questions and answer for this project, so this may be useful for your Viva. So the main, what is the primary purpose of the project? So the main aim of this project is to accurately predict and classify the cervical cancer and it into the 7 classes using the deep learning using the medical image data. So this will be helpful for the healthcare professional in early diagnosis and better treatment planning. And what is the data set used in the project? So we have used hello data set, which contains 17,304 medical images, and they have been classified into the 7 classes. And this data set, we have training, validation and test. Training contains 12,110 images, validation contains 3,111 images, test contains 2,083 images. So which deep learning architecture is used in the system? So we have used Xception architecture, which is known for its high accuracy and efficiency for the image classification task. So how much we have accuracy that we have achieved is 93% for the test and the validation score. And what are the tools that we have used for developing this project? So backend contains Python and Flask, frontend content HTML, CSS, JavaScript, deep learning content TensorFlow, Keras, development environment, Jupyter Notebook or VS Code, anything that you can use it. So how does the system work? So you'll be uploading the image, pre-processing, prediction, and the output will be shown. So who can use this system? So this system is designed for healthcare professional for assisting in the cervical cancer diagnosis and researchers working on the cervical cancer detection and the medical diagnosis. And does this system require high-end hardware? So while training the model, we require high performance processor, and when it is deployed system, you can use a normal standard local machine, sufficient computation resources in it. And how does this project differ from the existing system? So in the existing system, they are used numerical data set and machine learning model, but here we have used medical image data and deep learning model with the Xception architecture to achieve the higher accuracy and the detailed classifications of it. And what are the challenges that the system is constructed? So what are the challenges? The need for the accurate classification of the cervical cancer type, reducing the dependency on manual microscopy, providing a scalable solution for medical institution in resource constrained setting. So these are the system and these things addressed by our system. So how is the user experience optimized? So the web interface is designed to initiate allowing medical professionals to upload the images and view results easily, so that the system ensures quick prediction and clear visualization of outputs on it. And what are the limitations of the system? So although we have achieved high accurate, system may require large high quality data sets for continued improvement. For further improvements, we need large and high quality data set, and validation from medical professions to ensure the reliability in clinical settings will be helpful. This kind of limitations you can explain when they are asked about these type of questions. So in this way you can answer these questions. And this is all about the project cervical cancer prediction and classification using deep learning on medical image data. And thank you for